Question 2 on exercise set 1.3.3, grade 11. A brick is dropped from a height of 80 meters. How long does it take the brick to reach the ground? And what will be its velocity when it reaches the ground? At first glance, it doesn't look like we're given a lot of information here to work with, but it'd be surprising how much you know coming into this question. So where will we start? We see we got the brick at a height of 80 meters. It's going to be dropped to the ground. So I think that's going to be the displacement of the brick. Okay, it is just dropped, so I'm thinking we have a VI of 0. And we have an acceleration, it's going straight down, an acceleration of g, which equals 9.81 meters per second squared. So in fact, we have several pieces of information. Let's summarize them over here. We got VI, which is 0. Then we have displacement. It's 80 meters, 0.0 to be exact. We have an acceleration due to gravity of 9.81 meters per second squared. We don't know VF, but part B asks for it. And we don't know the time it takes. Part A asks for that. So what we really want to do is find time first. So we have a VI, a D, an A, or an acceleration. We want to find time. Man, that takes us right to this formula right here. Displacement is VI T plus 1/2 AT squared. I know I've always said if you don't know T, this is a bad one to go to, but if VI is 0, then this section right here, oh shoot, will go to 0. Because 0 times, no matter what T is still going to be 0. So we're left solving just for a single T variable, T squared. So let's go for that. We'll bring that up. And we know delta D is 80. And the VIT is 0, so I'm taking that right out. I got 1/2 A, which is 9.81 T squared we are solving for. Okay. So I've got 80 equals half of 9.81 is 4.9 T squared. Alright, algebra time. Divide both sides by 4.9. Oh, 4.9. Get rid of that. Yeah, 4.9. I'm left with T squared on the right. I'm left with 80 divided by 4.9 on the left. Now, I just want one T, not T squared, so I have to take the square root of T to get that. So I'm left with T on this side. I'm going to take the square root on that side and take the square root on this side. So I need the square root of 80 divided by 4.9. And that will kick out at 4.04 seconds. So it'll take 4.04 seconds for the brick to reach the ground. That's part A. Let's make that A right there. Okay. I still want to move this more over like this. Okay, let's go to part B. B says what's its final velocity. So let's remind ourselves what we got. We know we have a VI, it's 0. VF we want to know. We got a T of 4.04 seconds, but that's calculated. Calc. It's supposed to say calc. Calculated. So we won't use that if we don't have to. We've got an A, which is acceleration due to gravity of 9.81 meters per second squared. And we have our displacement, which is 80. 0 meters. Okay. If we can use VI, D, and A to find VF, we're laughing. And we do have the formula of displacement with the VF squared stuff in it. So VF squared minus VI squared all over 2A. Okay, let's bring this up here. Fill them in, so I've got AD equals VF squared minus 0 squared all over 2 times 9.8. 80 equals VF squared over minus 18, 19.6. Multiply both sides by 19.6, so I've got 80 times 19.6 equals V. Okay, let's move this over just a little bit. Erase that. Can't erase that. Once I move it, so let's get rid of that, is VF squared. So in order, I need to take square root of both sides to get VF. So square root of this side of this math, 80, 19.6. And we'll find that velocity final is 39.6 meters per second. Okay, so in our final answer, that's B. So we say, well, it took the brick 4.04 seconds to fall to the ground, and just before impact, it has reached a velocity of 39.6 meters per second. Finished.